transmission system yesterday. Different components of a transmission system. Clutch, how it works, okay. What are its functions, what are the design requirements, classification we have studied, principle of operation with the help of a video we have studied, different types of clutches yesterday we have studied, dog clutch, cone clutch, single plate clutch, multi-plate clutch, and centrifugal clutch we have completed yesterday. So we will move to the second component of the system, transmission system, that is the gearbox. Okay. So what do you mean by a gearbox? It is the heart of the transmission system. Okay. So mechanism that transmits the power from the engine crankshaft to the wheels. Okay. So it indicates a mechanism which can produce desired torque variations. What do you mean by torque variations? See, when you want to initially move a vehicle, you need a very high torque, which engine cannot produce directly because engine's capacity of producing torque is fixed. So if you have a gearing mechanism which can multiply the torque, 1 is to 2, 1 is to 3, 1 is to 4, etc. So in the first gear, say for example, it will be multiplied by 2 to 3 times. So you'll get heavy pulling so that it can take up the load and start moving. Once it starts moving, the amount of inertia will be less. So in the second gear, again the torque ratios will be varied and smooth movement will be there. Okay. This transmission system can be either manual or automatic, whatever you can see in a scooter like Honda Activa is the automatic system. Based on the accelerator itself, automatically the gear will be shifted. What you see in a bike, motorcycle, is a manual gearbox. You need to judge by yourself. So at which gear the vehicle can run comfortably. For example, if you want to initially move the vehicle, you cannot move it in third or fourth gear. Okay, a huge torque is required. You have to put it on a first gear, yeah, where huge fuel will be consumed, but torque multiplication will be more. The vehicle can start moving. Once it picks up the speed, you will switch on to the second, and so on. Okay, so transmission can be either a manual or automatic. The next question arises is why transmission or why gearbox is required? Can't we directly couple the engine shaft to the wheels? Okay. Yes, it is possible. Okay. But what happens, we will study about the implications. We'll come back to this sketch for a while. Okay. Just refer this sketch. If you want to couple the engine directly to the wheels, so what happens? There will be no question of any clutch here. No clutch, no transmission. That is, the gearbox will not be there. Okay, no drive shaft, no universal joints, nothing. But differential should be there because you need to divide the power equally to two wheels. So directly the engine crankshaft can be connected to the differential. This mechanism will not be there. Okay, if transmission system is not there in the vehicle. But what are the problems faced? So that we will discuss now. So that with that we can understand why a transmission system is required. See, if the vehicle has to run on a flat road, okay, then you can directly couple the engine to the differential so that directly the engine can drive the wheels. Okay, but you need to calculate the maximum possible load on the vehicle and design the engine such that it has to produce maximum torque. Okay, even at no, I mean even at a moving condition. So when the vehicle is stationary, when it just starts moving, okay, it needs maximum torque. You need to calculate that maximum torque and design the engine for that maximum torque. So what happens here? Once the engine picks up the speed, that much quantity of torque will not be required. Yeah, correct. So then what to do? You cannot speed up the vehicle because torque variation you cannot do. You cannot because transmission system is not there in the vehicle. First issue. The second issue is, for example, you are driving the vehicle in a very flat road, somehow without transmission system. Okay, at a higher torque, the vehicle keeps on running. Suddenly there comes a steep curve. You need to move the vehicle on a steep curve. So what happens with the available torque and load, the vehicle cannot pull. Yeah, it requires very high torque, but engine cannot produce because the torque produced by the engine it depends on the design consideration and it is fixed. So you cannot drive the vehicle in a steep. The vehicle immediately stalls. That is, it stand still at that position. If you don't apply the brake in the step, it starts coming back. Okay. Now the next issue is, say for example you want to drive the vehicle in a flat road itself, no question of any hills or no steep curves or no load variations, but what happens, all the time the engine produces very high torque. Okay, desired say one whatever 150 newton meter or 100 newton meter the engine is designed, it keeps on producing the same torque irrespective of load, irrespective of speed. So the efficiency of the vehicle goes down, and practically you cannot imagine a vehicle without any transmission system, because you go to anywhere, any place, okay, you cannot get a flat road throughout your drive conditions. The next question, you park your vehicle somewhere, okay, if you want to come back, how do you do it? If it is a two-wheeler, just you get down and pull it back. But if it is a car, is it possible? Highly impossible. Every time you cannot. It is possible to push it back, but one person cannot do it. Every time you cannot imagine that to be done. Okay, so you need to have certain transmission system which can reverse the direction of rotation of shaft also. Engine keeps on giving you the power. The gearbox, what does it do? It will rotate the shaft in the reverse direction, so your wheels start moving in the reverse direction, so that you can take your vehicle back. Correct. So these are the reasons why you need a transmission system. Even though engine is a heart which produces a torque, but that torque cannot be equally used under all considerations. Yeah, you need to vary the torque depending on your requirements, load, the direction of movement forward, backward, etc. So in order to accommodate that, we need a transmission system. Correct. So when you want to move the vehicle back, okay, you need to put it to reverse gear, wherein even though the engine gives a clockwise rotation, okay, the gearbox converts it into anti-clockwise and rotates the wheel in the reverse direction, so that you can take your vehicle back. Okay, so this is the reason why we need a transmission system. Okay. So this question, I was just going through one of the question papers, so I added it. Okay, why a transmission system is required. You can give these points as a justification. So what are the general functions of a transmission system? Okay, one is it has to produce the torque as and when required, depend on the speed. Okay, for initial movement of the vehicle, very high torque is required. When it starts moving, you shift it to the second gear, the amount of torque required is less, inertia is less. Okay, when you move it to the topmost gear, what happens directly, the transmission system shaft and the driver shaft, that is engine shaft, will be directly coupled. So whatever rotation engine rotates, complete rotation will be shifted to the rear wheels. So it has to provide the torque as per the requirements. Okay, okay. It provides tractive effort to start from rest, and also variation in torque, as that is what whatever traction is required to start the vehicle from rest, it has to give when you apply to the first gear. Okay, and the third one is it has to provide a neutral position. Yeah, always when you start the vehicle, you cannot press the clutch and keep waiting. Correct. So if you want to keep the vehicle in idle condition for some reason, say for example you are parked somewhere in a hot condition, you want to run your AC, so you will switch on the vehicle. Yeah, start the vehicle, put the vehicle in neutral condition. So neutral condition means even though the clutch is engaged to the engine, the wheels does not rotate. Correct. So if you put it to the first gear and leave the clutch, what happens? The engine is directly coupled to the rear wheels, so that the vehicle starts moving, or with the jerk it gets switched off. Okay. If you want to keep a vehicle in the idle condition, there should be a provision. Yeah, that provision is provided by the transmission system. So there is a particular position in the gearbox. If you keep the gear rod at that position, it is called as neutral. Even though the clutch is engaged with the engine, the wheels does not rotate. Okay, so that provision should be there. And reversing the rotational direction of the drive. So we discussed this. When you want to take the vehicle back and you move the vehicle in the backward direction, the transmission system or gearbox should rotate the wheels in the reverse direction. Even though the positive moment of the shaft is given to the gearbox, it has to be converted to anti-clockwise. Okay, there should be a gear mechanism which rotates the wheel, shaft in the reverse direction. So these are the some of the functions, or we can call it as the requirements of a transmission system. It has to provide the torque based on the requirements, rest condition to move fast moving condition. Okay, it has to provide an option for neutral position, and it also should have an option for reversing the vehicle. So these are some of the functions of transmission system. Okay. There are two types of transmission system nowadays. It has been a very wide topic. Okay, so we have automatic, semi-automatic transmission, etc. There are many varieties depending on the requirements. There are certain car manufacturers who give a both semi-automatic mechanism where you can drive the vehicle in a automated fixed mode in city drive, and when you come back to the long drive condition outskirts areas, you can make it to a manual mode so that the efficiency can be varied. Okay. So mainly there are two types of transmission system, manual and automatic transmission system. In case of manual transmission system, the vehicle is driven with the assistance of a gear shift and foot clutch. There will be a clutch as well. I am talking this with respect to a four-wheeler. Okay. In case of a two-wheeler, there will be a hand clutch usually. A foot clutch will not be there, hand clutch will be there. So in case of manual transmission system, the vehicle is driven with the assistance of a gear shift and a foot clutch. Okay. The other components required as flywheel, pressure plate, ring gears, clutch, etc. So other components required in the manual transmission. Whereas in automatic transmission, the gears are changed automatically corresponding to the vehicle speed. Yeah. So automated cars, what happens? Automatic transmission assisted. If you just put the gear knob to the forward condition, it moves in the forward condition. Depending on the acceleration you give, the speed of the vehicle, automatically the gear shift takes place. So why the efficiency of the automatic transmission system vehicle is low? See, it's a universal fact. If you keep on changing the gears, okay, what happens? The efficiency of the vehicle drops. Okay, there will be no continuous movement, so that there will be a drop in efficiency. In manual mode, what happens? Even the vehicle speeds down certain limit, you may not shift it from third to second gear. Okay, you adjust with the help of a accelerator without touching the clutch. You will be driving the vehicle, so that the efficiency will be relatively better. Here it is not like that. So if the speed is 21 kilometer per hour, say more than 20 kilometer, if it is set to third gear, automatically it will move to third. If it comes to 19, again it will move to second. So in a city drive, if you are going between 19 and 21 kilometer per hour for 1 kilometer, it shifts the gear multiple number of times automatically. But that is not the case in manual transmission. You will judge. Okay, when there is a real requirement, you will be shifting the gear. Otherwise, with plus or minus 5 kilometer per hour, you will be managing with the gears. Okay. So in a case of automatic transmission system, the gears are changed automatically corresponding to the vehicle speed. The basic components are: one is a arc modulator, torque converter, planetary gearbox, governor, computer. So it is all computer controlled, seals and hydraulic designs. Okay. So now we have to study the working of manual transmission system and automatic transmission system, one of the other. Okay. So coming to manual transmission system, just you take down a rough sketch. I have taken up a very simple two-speed transmission system. Yeah, for the discussion purpose, for working principle, we can understand. Later on, that can be extended to four, five speed, six speed, etc. Yeah, a simple two-speed sketch I have taken. Yeah, you can take down as a line diagram. Okay, wherever gear, collar, etc. are there, you can take it as a block. So I'll give you 2 minutes time. Just take down. First, we will discuss how is it manual transmission works with the help of a very simple two-speed driving mechanism. Please take down. Okay, so this is a simple two-speed transmission system which is showed in neutral position. So neutral in the sense, even though the engine, if it is running, and even though the clutch is engaged, okay, the shaft is engaged. Okay, the differential. I mean, this is the driver shaft. This is the driven shaft. The yellow color, whatever you can see, is the driven shaft, and this is the driver shaft. Even though both of them are coupled with the help of a clutch, here this shaft doesn't rotate. Okay, why we will discuss. Okay. So here it's a simple two-speed transmission. One forward and one reverse gear will be there in such a transmission. Yeah, the driver shaft, you can see this is the driver shaft, which is green in color, comes from the engine. Okay, through the clutch. So here there will be a clutch plate arrangement and an engine. Okay, when clutch pedal is pushed, the engine and the transmission are disconnected. That is, if you apply load on the clutch pedal in your car, so this shaft as well as the engine shaft will be disconnected. So this is the shaft coming from the engine, there will be a crankshaft here, in between there will be a clutch, so both of them will be disconnected. Yeah, when you release the load, both of them will be connected. Okay, so this the red color, whatever you can see, that is called as a lay shaft, LAY, or it is also called as a counter shaft. Okay, so this is the engine shaft or the driver shaft, this is the differential shaft or the driven shaft, and this is the lay shaft or the counter shaft. Okay, this helps in connecting the engine shaft and the driven shaft. Okay, so that is the function of the lay shaft. So a lay shaft or a counter shaft is located directly below the engine shaft. Okay, the lay shaft receives power from the engine shaft and it transmits to the required gear, okay, in the driven shaft. Right. Next, we have discussed about the driver shaft or engine shaft, lay shaft. The third is the driven shaft, the yellow color, whatever you can see, that is called as the driven shaft, which connects the gears, receiving gears or driven gears to the differential. Okay, the driver shaft, which is yellow in color, connects directly to the drive shaft through the differential. Okay. So it helps, the differential helps in driving the rear vehicles of the car. Okay. So the driven gears, so this blue color, whatever you can see, these are called as the driven gears. This is the driving gear. So these are intermediary gears between the driven gears and the driving gears. Okay. The One second, the purpose of the collar, so there is a collar here, you can see, okay, is to connect the one of the driven gear to the driving shaft. It will connect one of the driven gear to the driving shaft. So here it is a two gear mechanism. So initially this is in neutral position, you can see. Okay, so when you start the engine shaft or starts rotating from this gear, the lay shaft gear receives the power. So this wheel also starts rotating. So this part is an integrated mechanism. This gear starts rotating, all these gears will be rotating. Okay, so when these two red gears are rotating, these two blue gears are also rotating in rotating position. Okay, but what happens, so this driven shaft or differential yellow color shaft is mounted on a bearings. Okay, so whenever you shift the gear, say for example you want to move the vehicle in forward direction, this is a two gear mechanism. When you shift, this collar goes and attached to this blue gear. Okay, so what happens, so the vehicle starts moving, so the differential shaft also rotates. When you keep it in the rotation, I mean a neutral position, okay, only these two gears keep rotating, they will be on a free rotation, they will not be coupled to the differential shaft. Okay, so entire gear mechanism will be working, 1 2 3 4 5, all 5 gears will be working, but these two gears will be on a free rotation, they will not be coupled to the differential shaft. When you move this collar, how do you move this collar? When you apply a gear after applying the clutch, so when you press the clutch first, what happens, okay, so here the clutch disengages, okay, the driver shaft, so this system becomes neutral. So when you apply the gear after applying the clutch, so this collar, whatever is there, it goes and attaches to one of the gear. For example, if it is attaching to this gear, when you release the clutch, so this power will be directly transmitted to this first blue gear. Okay, so you can see in this sketch, so this is in first gear position, you have applied to the first gear position. So initially the collar was here, you apply the clutch and put it to the first gear, this collar will go and attach to this larger gear. So when you release the clutch, whatever engine power is there, that will be shifted to the lay shaft. Okay, from the lay shaft it will be going to the this larger gear, so that the vehicle starts moving in the forward direction. Okay, so you can ask a question, what about this gear? So this will also be rotating, but it will be on a free motion. Why? Because this yellow color shaft is mounted with the help of a bearings. Okay, it will not be a rigid, so this will be on a free rotation. Okay, whenever this collar will be directly mounted onto the differential shaft. So if this collar comes in contact with that gear, that particular gear rotation will be shifted to the differential. Suppose if you want to move the vehicle in the reverse direction. Okay, say for example you want to move the vehicle in a reverse direction, you will apply the clutch here so that this gets disengaged, so this part becomes stationary. Okay, then you will move this in the backward direction. Okay, so this rod comes somewhere here. Okay, so then what happens, this collar will go and attach with this gear. So when you release the clutch, okay, so these gears are arranged such that if this gear moves in the clockwise, this blue color gear will move on the anti-clockwise. So the gear mechanism is arranged such that, okay, if this is moving in clockwise, this will be moving in anti-clockwise. Okay, so you shift the gear to reverse, start leaving the clutch, I mean releasing the clutch. Okay, so what happens, this shaft, whatever this engine shaft will be coupled to this green shaft, so that the power will be transmitted via lay shaft to this, so that the wheel starts moving in the reverse direction. Okay, so this collar is the key member which will decide so to which gear it will be meshed. So this is about the working of a manual transmission. I have taken a very simple, okay, two-speed gearbox so that easily you can understand. Please make a note of this sketch, one of the gear positions, so that if they ask you to explain or write a note on a manual transmission system, you can take up this simple gearbox. Okay, so the first sketch, whatever you have taken down, it was in neutral position. So this sketch, when it is shifted to the first gear. So with this simple concept, you can easily explain. See, if there are any doubts, I'll give you 2 minutes time. Just type and send here so that we can discuss. Yeah, raise your hand, I'll unmute you. If this is clear, there are three types of gearboxes. Okay, the three types of gearboxes easily we can discuss, because principle of operation will be clear to you. Yeah, if you have any doubts, please let me know. See, I have made it very, very, very simple. Okay, I have taken a simple, okay, two gear. I have not taken any complicated line diagrams which you can see in the textbook. A simple sketch I have taken so that the concept can be understood very clearly. You have to explain about the driver shaft or engine shaft here. Okay, lay shaft or the counter shaft. Okay, driven shaft or the differential shaft. First, you have to describe these three things. Then you have to talk about the driving gear. Okay, so these are connecting gears and these are the driven gears. And